What if an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond?
On July 1st, 2025, astronomers in Chile made a discovery that immediately set the scientific world buzzing. Their telescope picked up a strange object named 3I/ATLAS, cutting across the sky, moving at a speed and angle.
Astronomers are now tracking a newly spotted comet 31 Atlas hailing from parts unknown. Now, it is only the third time such an interstellar object has been observed visiting our solar system. Take a look.
That marked it as something out of the ordinary. But the more scientists looked at it, the more unsettling the mystery became.
Some actual bona fide experts think it might not be your typical space rock or maybe any kind of rock or a natural phenomenon at all.
Could this really be just another comet, or is there something unusual hidden in its glow? And if the object is not what it seems, what might it mean for our place in the universe? Stay with us as we explore why scientists fear what 3I/ATLAS really is, and why the truth could be far worse than anyone expected. The discovery that shocked scientists. It began quietly on a cold night in Chile. The skies above the desert are among the clearest on Earth, which is why astronomers built the Asteroid Terrestrial Impact Last Alert System, better known as ATLAS there. Its job is simple: to keep watch for anything moving across the stars that might pose a danger to our planet. Most of the time, it catches common things like asteroids that wander inside the solar system, fragments of rock that burn up as meteors, or long-period comets on slow paths around the sun. But on July 1st, 2025, Atlas detected something that did not fit any of these familiar patterns. At first glance, it looked like a comet. It had a faint, misty halo that suggested ice and dust were evaporating into space. But when astronomers calculated its orbit, they were stunned. This object was not looping around the sun like a normal comet. Instead, its path was hyperbolic, which means it is not trapped here at all. It came in from outside the solar system, and once it swings past the sun, it will continue back into the void, never to return. This alone was enough to make scientists sit up, because interstellar visitors are incredibly rare. In all of human history, only two others have ever been spotted: Oumuamua in 2017 and 2I Borisov in 2019. Now, for only the third time, a traveler from another star had entered our cosmic neighborhood. The new visitor was given the official name 3I/ATLAS. The 3I marks it as the third interstellar object ever detected. Atlas refers to the telescope system that spotted it. Within hours of the discovery, observatories around the world turned their instruments toward it, eager to record details before the chance slipped away. Unlike planets or moons, which stay in place for centuries, interstellar objects flash past quickly, giving only a brief window to study them. At first, there was excitement, like this was a rare chance to peek at material that had formed around another star. Scientists hoped to compare its composition with that of comets and asteroids in our own solar system, looking for clues about how worlds form in distant places. But very quickly, the mood shifted. When researchers plotted the trajectory more precisely, they saw something deeply puzzling. 3I/ATLAS was not just drifting through space at random. Its orbit cut through the solar system in a way that lined up almost perfectly with the flat plane where most of the planets travel around the sun. Statistically, this is strange. Interstellar visitors should come in at odd angles because stars and their systems tilt every which way across the galaxy. The odds of one arriving in such neat alignment are small. Was this a coincidence or something else? As the object moved closer, astronomers also began to notice peculiarities in its brightness. Normally, comets shine because sunlight reflects off dust and ice, or because gas escaping from their surfaces glows when energized by the sun. But 3I/ATLAS didn't quite match that model. Its brightness profile, which was the way its light fell off across the halo, was unusually steep. Using standard calculations, the numbers suggested it was a massive object, perhaps 20 kilometers wide. That would make it far larger than either Oumuamua or Borisov. Yet such a large interstellar rock is extremely unlikely, because space between the stars is mostly empty. The chance of something so big wandering into our solar system is tiny. This left astronomers with an unsettling choice. Either 3I/ATLAS is far bigger than probability says it should be, or something about it is bending the rules. Some even began whispering about the possibility that it was generating its own light. If true, that would mean our standard way of estimating its size was wrong, and the object could in fact be much smaller. But then another stranger possibility crept in. What if the glow was not natural at all? The discovery of 3I/ATLAS should have been cause for celebration, a once-in-a-generation chance to study an alien comet. Instead, it quickly turned into a puzzle that made even seasoned scientists uneasy: the glow mystery. As the first days passed after its discovery, astronomers used every tool they could to measure 3I/ATLAS. Telescopes in Hawaii, the Canary Islands, and South America all reported the same thing. The object was unusually bright for its distance. Brightness in space can be misleading, so scientists always ask the same question: what is producing the light we see? In the case of comets, the answer is usually simple. Dust and water vapor escape from the nucleus when sunlight warms the ice, and that cloud reflects sunlight back to Earth. The bigger the nucleus, the brighter the comet. But that's not all. 3I/ATLAS quickly began to confuse the models. Its light was not fading or spreading the way astronomers expected. Instead, its brightness seemed to hold steady and decline at a sharper angle than usual. When calculations were made using these brightness patterns, the object appeared to be about 20 kilometers wide. For comparison, that is nearly 40 times larger than Oumuamua, the first interstellar visitor discovered 8 years earlier. The odds of finding something so huge passing through our solar system are vanishingly small. In fact, statistical models suggest that an interstellar body of that size should only appear once in tens of thousands of years, if ever. Yet here it was, shining as though it were a giant. This raised the first major suspicion. Maybe the glow was misleading. Some scientists suggested that 3I/ATLAS might not actually be reflecting sunlight in the usual way. Instead, it might be giving off light on its own. If that were true, then the object could be much smaller than 20 kilometers, perhaps just a few hundred meters across, but it would be disguising its size with a strange, self-generated glow. The idea sounded exotic, but it could not be dismissed. There are natural processes that can make an object emit light. Radioactive decay, for example, can create a steady glow if the surface contains unstable elements. Internal heat could also produce infrared radiation if the core is warmer than expected. But these ideas require unlikely conditions. Interstellar space is frigid and empty. An object that has been drifting for millions of years should have cooled long ago. For it to be producing enough light to mimic a 20-kilometer comet, it would need an internal power source on a scale we rarely see in natural bodies. That was when the whispers about artificial origin grew louder. Could 3I/ATLAS be more than a rock? Could it be a machine designed to shine or disguise itself as something natural? The thought was unsettling, and most astronomers rejected it as science fiction. But a few voices urged caution. Among them was Avi Loeb, the Harvard astrophysicist who had already stirred controversy by suggesting Oumuamua might have been an alien probe. He argued that the glow profile of 3I/ATLAS was worth investigating seriously. If natural explanations failed, then perhaps the artificial hypothesis deserved attention. Other astronomers disagreed strongly, pointing out that comets are notoriously unpredictable. Dust jets can make them brighter than expected, and unusual chemistry can alter the glow. To them, 3I/ATLAS was simply a large comet behaving oddly, nothing more. But the fact remained. Its brightness profile was unlike anything seen before, and no one had a simple explanation. Meanwhile, telescopes like Hubble and Gemini South provided more detail. They detected water ice mixed with carbon-based minerals and silicates, the same raw materials found in many comets. Yet the water appeared unusually pristine, without the heavy isotopes that most solar system comets carry. That meant the ice could have formed around a distant star under very different conditions. It was a direct sample of alien chemistry drifting into our solar system, and that alone was extraordinary. But it also meant the puzzle was not over. If this were just a comet, why did its light refuse to behave like one? The glow mystery began to divide the scientific community into two camps. One side argued that extraordinary claims require extraordinary evidence, and so far, the data still fit within the wide range of natural comet behavior. The other side pointed out that the numbers did not lie. The probability of such a massive interstellar comet was close to zero, so maybe the size estimate itself was wrong, and the light source was not natural reflection at all. Both sides agreed on one point. The next few months would be crucial. As 3I/ATLAS moved closer to the Sun, solar heating should trigger more activity, releasing gases and dust that could reveal the true nature of its glow. If it behaved like a normal comet, the mystery would fade. But if it continued to defy expectations, the possibility of something unprecedented would remain on the table. At this stage, no one could say for certain what was powering the light of 3I/ATLAS, the path through the solar system. When astronomers calculated the exact route of 3I/ATLAS, what they saw made them pause. Interstellar objects are expected to arrive at random angles, cutting through the solar system on steep or tilted paths. After all, stars in the galaxy are scattered in every direction, each with its own unique orientation. What's more shocking? The chances of a visitor aligning neatly with the same flat plane in which our planets orbit are extremely small. Yet that is precisely what 3I/ATLAS appeared to do. Its orbit followed a retrograde path, tilted only about 5 degrees from the ecliptic plane, like the giant invisible disk where Earth, Mars, Jupiter, and the other planets trace their journeys around the Sun. The odds of such an alignment happening purely by chance were calculated to be less than 1 in 500. For some scientists, this was an uncomfortable statistic. Was it a coincidence, or could there be another explanation? The strangeness did not stop there. As the object's path was mapped more carefully, researchers noticed that it was set to pass unusually close to several major planets. On October 30th, it would sweep within just inside of Mars. Later that month, it would come closest to the Sun at about 210 million kilometers, which is farther than Earth, but closer than Mars. Then, after curving around, it would head toward Jupiter, passing within 410 million kilometers of the giant planet. These distances may sound large, but in cosmic terms, they are remarkably close. Random interstellar visitors should pass by on wide, uncaring routes, missing the planets by hundreds of millions of kilometers. For 3I/ATLAS to thread such a narrow course raised questions. The probability of an object from another star making close approaches to 3 major planets in one pass was estimated at just 1 in 20,000. The numbers made the puzzle harder to ignore. One detail unsettled astronomers even more. 3I/ATLAS would reach its closest approach to the Sun at the exact time when Earth would be on the far side, hidden by the Sun's glare. In other words, Just as the comet, or whatever it was, would be most active and most interesting, it would slip out of sight from our planet. No ground-based telescope would be able to see it directly during that critical moment. If someone had wanted to avoid human observation, they could hardly have chosen better timing. Some scientists brushed this off as mere chance. After all, coincidences do happen, especially when dealing with the immense scale of space. Others, however, noted the curious precision of the orbit. Avi Loeb, along with collaborators, suggested that this might resemble a reverse solar Oberth maneuver, which is a theoretical strategy in which a spacecraft uses the gravity of a star not to speed up, but to slow down and remain in a system. If 3I over ATLAS were artificial, such a maneuver could allow it to shed velocity and perhaps even linger inside our solar system rather than passing straight through as natural objects must. The suggestion was bold and controversial. Many astronomers criticized it as speculation with no solid proof. Yet even critics admitted that the trajectory was unusual. At the very least, it offered a chance for close study. Space agencies began planning to use every available telescope to capture the object during its visible phases. The James Webb Space Telescope prepared to use its infrared sensors to measure temperature and energy output. Meanwhile, researchers considered whether the Mars Reconnaissance Orbiter could turn its high-resolution camera toward 3I/Atlas during the October flyby, providing the sharpest images ever taken of an interstellar visitor. The path of 3I/ATLAS turned what could have been an ordinary discovery into a story of growing suspense. The object was not only strange in its light, but also strange in its journey, threading a line through the planets with uncanny precision. Was it the work of chance, guided only by the blind hand of gravity? Or was there something more deliberate at play? Whatever the truth, one thing was clear. Over the next few months, as it drew closer to the sun and brushed past the planets, 3I/ATLAS would give humanity a rare opportunity. Each observation could bring us closer to answering the question: was this just another comet on a passing flight, or a messenger carrying secrets from beyond the stars? The missing heat problem. When comets travel through our solar system, the sun's heat usually leaves behind clear fingerprints. As sunlight strikes the frozen surface, the ice begins to vaporize, releasing gas and dust into space. This process, known as outgassing, creates a bright halo around the comet's core and a streaming tail that astronomers can track with precision. But 3I/ATLAS refused to behave. Despite approaching close enough to the sun for its icy layers to melt, the object showed little to no thermal response. Instruments designed to measure heat detected almost nothing. Where scientists expected glowing jets of vaporized gas, there was silence. It was as if the sun's warmth passed through the object without leaving a trace. This discovery raised urgent questions. Was the object made of a material unlike anything previously found in space? The missing heat signature left scientists divided. Some argued that the object was a fragment of a broken planet, hardened and stripped of volatile elements. Others suggested it was wrapped in a kind of crust that sealed in its inner core, preventing gases from escaping. Yet a more unsettling idea began to circulate in whispers. What if 3I/ATLAS was not a natural object at all, but something engineered? Every telescope turned toward it seemed to confirm the same unsettling fact. 3I/ATLAS was cold, quiet, and refusing to play by the rules of comets. Could this silence mean the object was dead rock drifting aimlessly? Or was it hiding something beneath its still and frozen surface? One of the first things astronomers looked for in 3I/ATLAS was water. Comets are often nicknamed dirty snowballs because they contain ice mixed with dust and minerals. When they approach the sun, the ice begins to vaporize, forming bright clouds and tails. But 3I/ATLAS offered another surprise. Observations using infrared telescopes revealed water ice on its surface, yet the ice was unlike anything normally found in our solar system. It appeared chemically pristine, lacking the heavy isotopes that usually mark comets formed around our sun. This suggested the ice had formed in a completely different stellar environment, far from our familiar neighborhood. Essentially, it was a sample of alien chemistry drifting through space. Even more puzzling, the ice did not behave as expected. Comets usually release water gas when heated by the sun, creating visible jets and measurable increases in brightness. 3 I/ATLAS, despite approaching the warmth of the inner solar system, showed little outgassing. The ice remained stubbornly frozen, as if insulated or protected. This added to the mystery of its glow. Was the faint light we saw simply reflected from the sun, or was there something more unusual causing it to shine? Scientists began to consider that the ice could be a form of camouflage. Perhaps 3 I/ATLAS was coated with this material to hide its true nature, whether natural or artificial. Dust, ice, and debris could accumulate over millions of years as it drifted between stars, forming a shield. Alternatively, some wondered whether the water itself might be evidence of design. Could an object carrying water have been engineered for a purpose we cannot yet imagine? Every piece of data from 3 IATLAS deepened the puzzle. Its pristine water ice, strange glow, unusual path, and impossible speed seemed to defy natural explanations. Observers were left with a difficult choice: classify it as an extraordinary comet, or consider the unthinkable possibility that this was something far more advanced, something artificial. With each passing day, astronomers around the world trained more instruments on 3 I/ATLAS, hoping to catch a hint of activity. Any small change in brightness, any sudden release of gas could provide clues. The water ice puzzle had become central to understanding this mysterious visitor. Its behavior might ultimately reveal whether it was a natural interstellar traveler or a cosmic object unlike any seen before. Could this be a natural wonder or evidence that we are not alone in the cosmos? Does it indicate the beginning of a story that will change science forever? Let us know in the comments section. We hope you enjoyed watching this video. Remember to like, share it, and subscribe for more. Also, click the next video showing on your screen. You will enjoy it.